My name is Pacheco. I'm from Crunchy Data, and today we're going to be talking about AI in Postgres as soon as we get the presentation up. And here we go, perfect. So you may ask yourself, what does Postgres have to do with AI, and why Postgres at all? Well, Postgres project started in 1986. It has been around for almost 40 years. It is reliable, it is feature-rich, extensible, and most importantly, it's open source with no central owner. Taking a look at many of the features available in Postgres, I'm just going to highlight a couple. For example, you can access data outside of Postgres, not just SQL data, but NoSQL, file data, geodata, and much, much more with foreign data wrappers. You can create indices that have a where clause that will only fire when the condition is met. You can store JSON as a binary in your database and still query it. You can do publish and subscribe in your database asynchronously through listen notify. Imagine being able to send information out to your clients in real time based off of the state of your data. And of course, you can use partitioning to manage large data sets. But today, we're going to talk about using vector. PG Vector is a new extension. It's been around for about 2 years, and it enables the indexing and the querying of OpenAI embeddings in Postgres. So to get started, we loaded some data into a recipes table in a public schema. We have an ID column that's an integer, a name and description column that are text, and then we have an embedding column that is of type vector. And this embedding column, that vector data type, comes from the PG Vector extension itself. So we loaded up about 1,200 recipes into this table. We take the data for classification, which is going to be the description of the recipe. We're going to run it through an OpenAI model and get back a bunch of embeddings. To do this, we used an OpenAI Ruby gem where we connected to the OpenAI client through an access token. We submitted each of these descriptions into the client, got back these embeddings, and then wrote them back into the database to correlate them with the data that we had stored previously. And this now gives us the ability to gain some insights about our data. So, what is an OpenAI embedding? Well, it is a tokenized float value that is used to measure related relationships between texts of strings. So here, we have examples of some of the embeddings that we got back. So we're going to query for similarities. So by a show of hands, who likes pizza? Right? Like just about everybody. Everybody likes pizza. So we're going to compare the embedding from one recipe to another, and in our results, we're going to grab the ID and name from two different recipes. And what we're looking for in our subquery is we want to compare the embeddings of our recipes to a recipe that has the name of pizza. And we're just going to give me the top four. So what are the top four most similar recipes to pizza? Well, obviously, pizza itself being an exact match is going to be at the top of our list, but then we see that we have 12-inch frozen pizza and chicken parm, which, while it is not pizza, is similar enough that it made our list, and pizza treats. Well, in addition to finding similarities, we can also do similarities with exclusions. So let's say, as an example, that, well, I don't want pizza today. I love pizza, but I've had enough. I want to find something that is like it, but not pizza. So the same query that we had before, what we're doing now is we're adding an exclusion clause with a where that says, give me all of the results that are like pizza, but where the name does not include pizza for recipe number 2. And we will see that we get some new results. We still have chicken parm from the previous result set because that had been identified as close to pizza. But then we have hamburger parm, eggplant parm, and lasagna. Well, what if I want to learn about something that is the opposite or something that is dissimilar? So using a similar query, we're going to again get the ID and name from recipe 1 and 2, but now I want to compare it to a corn dog. But more importantly, if you look in the order by clause, what we're doing is we are taking the list of results in descending order. So this is going to give us the least similar. So when you say, well, what would be the least similar or opposite of a corn dog? Well, in this case, a salad. If corn dog was to have an opposite, then I would say a salad is likely it. So this only scratches the surface of what you can do with pgvector and AI. I encourage all of you to install pgvector into your Postgres environments, run your data through an OpenAI model, and see what insights you can glean with your data. So a little bit about me. Again, I'm Bob Pacheco. I'm a senior solutions architect at Crunchy Data, 25 years of experience. I specialize in running Postgres on OpenShift and other cloud platforms. I have a couple of blogs out there that focus on Postgres with GitOps, Day 2 operations, and CI/CD. If those things interest you, you can find them at crunchydata.com. If you have any questions about running Postgres on OpenShift or any other cloud platform, you can see me here at the conference or shoot me an email at bobpacheco@crunchydata.com. And a little bit about Crunchy Data. So Crunchy Data is the Postgres company. Postgres is all that we do. It is our passion and reason for existence. We submit about 30% of the open source code to the Postgres project. We author and maintain several Postgres ecosystem applications to include PG Backrest, PostGIS, and others. And we are a proud Red Hat partner. We support several Red Hat applications, some of those you see here. And incidentally, it's serendipitous that I followed Kyndryl. Kyndryl is the world's largest commercial implementation of Ansible automation platform with over 700,000 servers managing over 2 exabytes of data. Kyndryl did a joint use case with Red Hat, making this information public, and it just goes to show the power of running Postgres on OpenShift at scale. So, why Postgres? Why not Postgres? It's reliable, it's secure, it's proven, and it is continuously innovating.